So another type of examples, for that we need formula of these two and another 4, right? We list out this formula in our first lecture. So just how this comes, ये कैसे आई, कहाँ से आई, वही आपको दिखाता हूँ। और इसका जो इंटीग्रेशन हम फाइंड करेंगे वो मेथड हम एग्जांपल्स के लिए भी अप्लाई कर सकते हैं। जहाँ सॉल्यूशन करना है वहाँ अगर जो ये फॉर्मूला आएगी तो हमको वो डायरेक्टली अप्लाई करना है फॉर्मूला, राइट? सो फर्स्ट इज 1/x² minus a². It is given 1/x² minus a². So I am simplifying this first. As I told you, simplify as much as possible. So this is a² minus b² form, right? So a² minus b² form, that is the factor of this is x minus a into x plus a, right? Now I am adjusting this denominator in numerator, so that is this is denominator is x minus a x plus a. So in denominator we want a 1, a constant one. That means we can't want this variable x. So if I am writing this x plus a and substituting x minus a, then what is our answer? This x will be cut and minus minus plus. So this is 1/2 a. It means we divided and multiply by twice a, right? So this is the meaning of this. So I am adjusting this denominator in numerator such that we have to cancel this variable x. So I am putting minus sign between these two factors. So this a and this minus minus plus a becomes twice a. It means we multiply by twice a. So we have to divide by twice a. So after bifurcating this, what we get? 1/2 a. See, this is your answer, right? Now bifurcating this, x plus a will be cut. So this is x minus a minus, this is minus, x minus a will be cut. So answer is 1/x plus a. So now substituting this value in here, therefore integration 1/x² minus a² dx is equal to 1/2 a is constant. So I am keeping outside the integration sign into 1/x minus a minus 1/x plus a dx. This is the answer. Now derivative of the denominator is in numerator. So answer of this is, you have a formula that you know, f dash x upon fx integration dx. Then answer is log of mod f of x plus c. This is your standard formula. We applied for many questions. So answer of this is derivative of the denominator is in numerator. Same thing, derivative of the denominator is in numerator because derivative of x is 1 and derivative of a is 0. So answer of this will be 1/2 a log of mod x minus a minus log of mod x plus a and plus c. Now we have formula log a minus log b is log a upon b. So applying that formula, what we get? 1/2 a. This is log a, that is x minus a upon b is x plus a and plus c. So this is nothing but that is your answer, right? Now similarly, if you want to prove this, you can prove using same way this. Either instead of this, you can write for second formula. Second formula is 1/a² minus x². So taking minus common, what will we get? You get 1/x² minus a². And same procedure, same thing. And here is minus. So minus goes to log into the power. So they are reciprocal. You have to take the reciprocal. That is, this comes to the numerator and this goes to denominator. That is your answer, right? Either you can split out like this, right, and then simplify. You will get your answer. So I'm leaving this for you as homework. Do it yourself. Do it yourself. DIYS. Okay, do it yourself. So this is for you, right? This is for only understanding of your concept, how this formula is comes, how we derive this formula. Suppose you forget the formula or you have a confusion between this, if you know this, then you can derive the formula, so you can save your marks. That's why I am explaining this, right? Then you have a third formula of this is integration 1 upon x square plus a square dx, that is 1 upon a tan inverse x by a plus c. This is your third formula. 1 upon x square plus a square is 1 upon a tan inverse x by a plus c, right? Now in this type of question you have to assume for x, that is you have to take a trigonometric substitution, right? You have to apply trigonometric substitution. So you know you have three identities, right? One is sine square theta plus cos square theta is 1, another is 1 plus tan square theta is sec square theta, and 1 plus cos square theta is cosec square theta. So in this type of questions, forget integration, right? It is given x square plus a square as we did in differentiation. So x is your x, that is sine constant, and this constant is your either 1 or whatever it may be. So this is 1 plus, this is 1 plus. So 1 plus either tan square theta, either cos square theta. So you have to assume x is equal to a tan theta. What you have to assume? X is equal to a tan theta. So we assume that let x is equal to a tan theta. X is equal to what we assume? A tan theta. So differentiating this, I am saying differentiating this not with respect to, right? So differentiating this, that is dx is equal to a constant, derivative of tan theta is sec square theta d theta. So dx is equal to a sec square theta d theta, right? So suppose this is the given, then what you have? Sin square theta is 1 minus cos square theta, that is 1 minus. 1 minus is what? Either cos square, either sin square. And for this sec square and cosec square, 1 plus tan square. Either sec square minus 1 or cosec square minus 1 is something minus 1 is sec or cosec square minus 1. 1 minus is sin square cos square, that you know we learn in differentiation. So now this is here. So taking this, what we get? I is equal to integration 1 upon x square plus a square dx. Now substituting this value, x is equal to a tan theta and dx is equal to a sec square theta d theta. So this is a sec square theta d theta, I am writing it last. X is a tan theta, so square of dx is a square tan square theta plus a square into d theta. So taking a square common, what we get? This is integration a sec square theta and a square is common, that is 1 tan square theta, tan square theta plus 1 and d theta. A square cancel. 1 plus tan square theta is again sec square theta is again sec square theta. So answer of this is, this is a and this is a square. So 1a is remaining. So 1a integration d theta and integration of 1 is theta, that you know. So answer of this is 1 upon theta plus c. And what is theta? Theta is from here is x by a. Tan theta is x by a. So theta is equal to tan inverse x by a. So this is very important thing. So theta is tan inverse x by a. So answer is 1 upon a tan inverse x by a plus c. That is your another formula, right? So you have to only remember these three formulas. This is 1, 2 and these three, right? But why I am explaining this? If you forget or if you have a confusion then you can easily derive the formula within a 1 minute, right? And you save your marks due to confusion. Okay. So another three formula of with root, right? We saw previously three formula without root: 1 upon x square minus a square, 1 upon x square plus a square, and 1 upon a square minus x square. Now these all three are with root. So first, fourth formula, this is given root x square minus a square, right? So this is here given root x square minus a square. So this is of the form root x square minus a square. So what is your substitution? X is equal to a something minus 1. Something minus 1, that is, you have this formula 1 plus tan square theta is equal to sec square theta. So sec square theta minus 1 is equal to tan square theta. So something minus 1, constant is 1. So x minus 1, so x is sec theta, but here instead of x, here is also instead of a 1. Instead of 1, here is a. So we have to assume x is equal to a sec theta. X is equal to a sec theta. So we assume, right? So assumption, right? So what we have to assume, x is equal to a sec theta, right? So we are going to assume this x is equal to a sec theta. Either x is equal to a cosec theta, but we are going for sec theta. So we assume that let x is equal to a sec theta. So differentiating this, what we get, dx is equal to a as it is. Derivative of sec x is sec x into tan x, that is sec theta into tan theta. So sec theta into tan theta into differential of that is d theta, right? Now substituting these all values here, what we get, I is equal to integration dx upon square root of a square minus x square, that is integration dx is a sec theta tan theta, I am writing d theta last, this is under root a square minus x square is a square sec square theta, right? And last d theta remaining, right? So now this is a square is common, so a square common takes outside the root, that is a. So we get integration sec theta tan theta, a will be cut with this a. So I am not writing here. So this is under root 1 minus sec square theta, 1 minus sec square theta d theta, right? What we are doing, we are making some mistake here. X square minus a square, this is x square minus a square. So this is plus and this is minus. So taking a square common, this is sec square minus 1. So sec square minus 1 is tan square theta, and square root of tan square theta is tan theta. So what we get, this is equal to integration sec theta tan theta. We write, instead of this, we write this formula. That's why here is a problem, right? We have to write this. Okay. So sec square minus 1 is tan square theta, and square root of tan square theta is tan theta, and d theta as it is. So tan will be cut. So this is integration sec theta d theta, and integration of sec theta is log mod sec x plus tan x, that is log mod sec theta plus tan theta plus c dash, I am writing plus c dash. Now sec theta, from here sec theta is x by a, right? So sec theta is x by a, sec theta is x by a, right? So this is under root x square minus a square, this is under root x square minus a square. So sec theta is x by a. So answer of this is log x by a plus tan theta is this upon this. So square root of x square minus a square upon a and plus cs. So now this is a is LCM. So this can be written as I is equal to integration. Sorry, integration is over now. So we are in simplification mode. This is log. Taking a LCM, we get x plus under root x square minus a square upon a and plus cs. Now this is log a upon b is log a minus log b. So I is equal to log a that is x plus under root x square minus a square minus log a plus cs. Now a is constant, means log a is also constant. So instead of this whole term, I am assuming that c. So your final answer will be I is equal to log x plus under root x square minus a square plus c, where c is equal to cs minus log a, where cs minus log a is equal to we assume c. So this type of simplification is also important in numericals. While you are solving the numericals, you have to simplify this thing, right? If you get any constant, then you have to merge that constant with constant, arbitrary constant c, right? Now similarly, this is x square minus a square, this is x square plus a square. Now we have to simplify. Just I am going to suggest assumption. This is x square plus a square, that is 1 plus is either tan square theta, either cos square theta. So in this you have to assume x is equal to a tan theta. For second, you have to assume x is equal to a tan theta. Then integrate, simplify, differentiate first, then simplify and integrate. You will get your answer very easily. And this is a square minus a square. 1 minus, this is 1, constant is 1, minus 1 minus is either sine square theta, either cos square theta. So 1 minus sine square cos square. So you have to assume x is equal to a sine theta. So in third, assume x is equal to a sine theta and simplify, you will get your answer, right? So you have now new 6 formula, that is root 1 upon first 1 of integration in 1 upon x square minus a square dx is 1 upon twice a log mod x minus a upon x plus a. Integration a square minus x square dx is 1 upon twice a log mod x plus a upon x minus a, and under root x square plus a square is 1 upon 8 tan inverse x by a. That is a 3 formula which we derived before this, okay? And another 3 formula, 1 upon root x square minus a square is log mod x plus as it is. Similarly here, log mod x plus as it is. So for x square minus a square, x plus a square, you have only, if you want to remember one formula, then remember this: log x plus, this is minus, then minus, and plus, then plus. So this is plus, then plus. So you have to remember only one formula: under root x square plus a square, either x square minus a square, x square plus a square, either x square minus a square. Answer will be in root. Answer will be log mod x plus as it is square root, right? And for x square minus x square, now you know derivative of sine inverse is 1 upon under root x square minus a square. So under root x square minus a square is there, a square minus x square. Then you have to apply sine inverse formula. Then you have to apply sine inverse formula, because here is x by a, right? So you have to apply sine inverse formula, right? So this 6 formula makes a very tough for you, right? It's a confusing formula with root and without root. So you have to practice this formula. So write down this 6 formula 10 times today, right? And for next 5 days you have to write each and every formula, right? These 6, right? For next 5 days, always write 10 times before going to sleep, okay? So you will remember this formula by heart, okay? Now in some particular functions integration, there is a 7th type of integration, That is, you are given a quadratic equation, 1 upon quadratic equation, either in square root, either without square root. Then what you have to do? Then at that time you have to make this a perfect square by finding out a last term. And you have a formula for last term is equal to middle term square divided by 4 into first term. Right? So find out last term using this formula, make it perfect square, and if you make this a perfect square, then you have a formula of this, either x square plus a square minus x square, either 1 upon a square minus x square. This formula you have, and after making a perfect square of this, you have to apply any one of this formula. If there is a square root, then again the same thing, make it perfect square by find out the last term, and then apply any one of these formula, x square plus a square, either under root a square minus x square. So first 6 formula are applicable here in this type of question. So we have to remember, if it is given in quadratic form in denominator with square root, either without square root, then you have to find out the last term, make them perfect square, and apply out of any one formula, right? First six formula you have to apply there. Okay. Now then you have another form is just like this. Eighth form is px plus q integration upon ax square plus bx plus c dx, or it is given in square root, that is px plus q, right? That is px plus q, right? And this is in square root quadratic equation, ax square plus bx plus c dx, right? So find out these type of integrals. These all are methods, right? While we are going to solve questions, then we have to apply these all methods. So you have to remember, right? So in this video lecture, we are not going to solve the questions, right? We are going to solve from next video lecture, right? So in this lecture only you have to see how to solve the question. There is the method you have to know, right? So now in this type of question, what you have to do? You have to assume for this px plus q is equal to m into d dx of denominator, that is ax square plus bx plus c, and plus another constant n. You have to assume this numerator is equal to any constant into derivative of the denominator plus another constant. So derivative of this denominator is apx plus q is n. This is twice ax plus b and plus n. So this will be px plus q is equal to twice a mx plus this is bm plus n. Now substitute this px plus q here. What we get? So we get I is equal to, here we get I is equal to, so I is equal to px plus q is twice a mx, right, plus bm plus n whole upon square root, either without square root, ax square plus bx plus c, and this is dx, right? So this is the last method of this type of particular integration, and all 7 formula are applicable here. All first 7 formula means any one of the 7, either 1, 2, 3, right? So now taking separate, this is what we get, twice amx, right? Now from here you have to find out the value of m and n, that we forget. So you have to find out the value of m and n. So if you find out the value of m by comparing both sides, so what is p? Coefficient of x is p. Here coefficient of x is twice m. So p is equal to twice a m. So this implies m is equal to p by twice a, and constant is q. So q is equal to bm plus n, and substituting value of m here, we get b into p upon twice a plus n, right? So n is equal to, we have to find out m and n, so n is equal to q minus this, so n is equal to q minus pb upon twice a. So substituting this value here instead of this, so m is p upon twice a, so I will be p upon twice a, m, ddx of, this is ddx of ax square plus bx plus c and plus n, n is this b into q minus twice pb upon twice a, pb upon twice a, this is n, and this is ax square plus bx plus c, right, dx, and this is integration. So this is our stereotype methods. You have to apply same formula in each and every questions, right? So what you have to do, first take numerator is equal to constant into ddx of denominator plus some constant. By comparing, find out the value of m and n as we find out here, right? If there is some mistake, then it's accepted, right? Now separating this, what we get, p upon twice a is constant, integration ddx of ax square plus bx plus c whole upon ax square plus bx plus c dx, and plus this is constant, so q minus pb upon twice a is constant, and integration 1 upon ax square plus bx plus c, and this is dx, right? So this is derivative of the denominator is in numerator, so apply log formula. So here you will be get p upon twice a into log ax square plus bx plus c. In each and every example of this type, this is the fixed formula, derivative denominator must be there in numerator, and then q minus pb upon twice a, and apply formula number 7. Apply method 7 here, make it perfect square, find out last term, make it perfect square, and then apply first 6 formula. So all formula are connected within this question, right? Now similarly, if there is a square root, then nothing. You have to adjust the formula. Derivative of the denominator is in numerator and denominator is in the square root. Then answer is 2 root of x. And again same formula in root. There is 4, 5, 6 formula, right? So these are the ways that how you have to solve the question. So from next lecture we are going to solve the questions. Okay? So do remember this thing.